Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is gladiator fighting. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. There are n gladiators standing in a field. They will fight till only one gladiator is left and the other n-1 gladiators have been defeated. Initially, everyone has a skill factor of 0, but every fight that a gladiator wins, his skill factor will increase by 1. There will be exactly n-1 rounds. Each round, two gladiators that are not yet defeated will come and fight, and one of them will win and the other will be defeated. The entertainment level of a fight between gladiators of skill level X and Y will be X plus Y. Now it is possible for a low skill gladiator to win. Our task is to find the minimum and maximum possible total sum of entertainment level over all fights. For the input format, we have t test cases, and for each test case, we'll have a single line that will contain the integer n, that is the number of gladiators. As for the output, on a single line, we'll have to output two integers, the minimum and maximum possible sum of entertainment levels. As for the constraints, number of test cases will go from 1 to 99, and the number of gladiators will go from 2 to 100. Let's see some sample inputs. So for the first sample input, there are two gladiators. Now as we know, each gladiator has an initial skill level of 0. So once these two gladiators fight, one of them will lose and the other will win. And the sum of their skill is going to be the entertainment level, and that is 0. Since now only one gladiator is left, there will be no more fights, and the game ends. Therefore, the minimum and maximum both are 0 and 0. For the next fight, or the next test case, we have three gladiators. In this case again, their initial skill level is 0. Now let's assume these two gladiators will fight. One of them will lose and the other one will win. Since this gladiator won, its skill level will increase by 1. Now again, this gladiator, the remaining ones will fight. Now again, one of them can win. Now if this one wins, this gladiator's skill level will increase by 1, and if the previous gladiator that won the game wins, its skill level will increase by 1 and make it 2. But for the current match, the skill level is 0 and 1. Therefore, the entertainment levels are going to be 1 plus 0, that gives us 1. So in any case, both the minimum and maximum, again here, both are going to be 1. Let's see how we can approach the solution. Since we know that we have n gladiators, we want them to fight and we want to achieve two types of score. One is where we get the minimum and one where we get the maximum. When we want to get the minimum, it is ideal for us that the previous gladiator that won loses the second time. So let's take an example. Let's assume these two gladiators fight. One of them will lose and the other one will increase the skill level by 1. In this match, the entertainment level was just 0. Now let's assume again the gladiator that won fights another gladiator. Now if again the same gladiator won, for this match the entertainment level will be 1 irrespective of which gladiator wins. But if the one that has already won wins again, in the next match, if the same gladiator wins, the entertainment count will increase by 1. That is, now we will have to add 2 because 2 plus 0 will give us 2 and the entertainment level will increases. So for us to make it minimum, it is ideal for us that the gladiator that has already won loses the next match. So in this case, when these two gladiators fought, the entertainment level was 0. One of them will win. In the next match, again, the entertainment level is 1, but now the gladiator that won previously will lose. This will make this gladiator's level's skill increment by 1. Again, when the next fight happens, the entertainment level still remains 1, and now this gladiator will lose again. So the one that has the lower skill level will increment it by 1. And finally, again, when the last match happens, again we'll have the same thing. The gladiator that has already won will lose. So in this case, what we'll do is we'll make sure that any times a gladiator match happens, the entertainment level will always be less than equal to 1. So in this case, As you can see that we have 5 gladiators, and in the final match we only get the maximum or the sum of all entertainments is just 3. That is, minimum is n minus 2. As for maximum, we would want that the gladiator that is winning always keeps on winning the next matches as well. So in this case, when these two gladiators are fighting, the entertainment level, let's write it here, when these two fight, the entertainment level is 0. Now again, one of them will win. In the second match, now again, the gladiator that has already won will win again. So again, in this case, the entertainment level is 1, but the gladiator that won will increment the skill level by 1. So now this becomes 2. Again, when the third match happens, the entertainment level will increase by 1 and it will become 2. And finally, when the last match happens, the entertainment level increases by 1 again. As you can see that the entertainment level here keeps on increasing, and with this is nothing but we will have to take sum of all these numbers, that is n minus 1 into n minus 2 divided by 2, that is sum of these whole numbers. So with this we know that for minimum our answer is nothing but n minus 2. That means all the gladiators that have won will lose the next match, and for maximum there is only one gladiator that will keep on winning all the matches, and this gives us the sum of the whole numbers. So with this we'll get our solution. Let's see how we can implement the solution in C++. So for each test case we call the function solve. In solve we take the input of n. As we have seen, the minimum is going to be n minus 2. To make sure that we don't go negative, because the score can never go negative, we will take the maximum in both the cases. So minimum is nothing but max of 0 and n minus 2, and maximum is nothing but max of 0 and the sum of whole numbers as we have seen in the approach. At the end, we print both the minimum and maximum, and as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n, get the minimum and maximum as per the approach we have seen. At the end, we print them. And as you can see, I've got an AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.